It's a well-known saying, nothing comes from nothing. If we now put this into a galactic context, an exciting question arises. How could the universe literally come into being from nothing? For our terrestrial lives, something can only be formed if components exist to build it. But where did the material come from that made the hour of birth of the cosmos, thus the Big Bang, possible? Together with you, we'd like to take a closer look at this profound topic today. What do experts have to say about this central question? And can it be answered at all with our current knowledge? Let's go in search of clues together. Excited about the groundbreaking discoveries and great mysteries of the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. Show us with a thumbs up that we can keep you engaged with the content of our videos. The end as the beginning. No matter if it's the Big Rip, the Big Crunch, or the Big Freeze, even if theories differ from one another, they all end in the same scenario, the end of the universe. If one follows these hypotheses, then one day the last star in the cosmos will burn up. Afterwards, the universe will change into a lightless place of emptiness. In that dark epoch, gigantic black holes will consume all remaining matter, before finally evaporating themselves into a final act of destruction. Space will expand until even the faint light from the evaporating gravity monsters is too dispersed to interact, and the activity of the cosmos will come to a complete halt. At least, that is a widely held view among scientists. While many researchers regard such a process as the final end of our galactic home, however, some experts recognize in it something completely different, namely the beginning of a new universe. In fact, some researchers are convinced that it was just such a dark, cold, and empty universe that was the basis of the Big Bang. However, before we go deeper into this exciting thesis, we should first address another, no less exciting question. How did the first physical matter actually come into being? If we want to explain the emergence of stable matter from atoms or molecules, it becomes clear that nothing of the sort existed either during the Big Bang or in the millennia that followed. What we do know is that the first atoms formed from simpler particles as soon as external conditions cooled enough to follow the formation of complex stable matter. We also know how these atoms later fused into the stars to form heavy elements. However, our state of knowledge does not provide any information on how something can be born out of nothing. So let's turn the cosmic wheel of time back even further. Protons and neutrons, which together form the nucleus of atoms, are considered the first long-lived matter particles in galactic history. It's generally assumed that they were created immediately after the Big Bang. Before that, however, no matter existed in the classical sense. Fortunately, physics allows us to trace the timeline back a bit further, namely, to those processes that took place before the birth of stable matter. The Planck era. Within physics, that era is called the Grand Unified Theory. In detail, this theory is based on the fact that at the time of the Big Bang, 3 of the 4 known basic physical forces, namely the strong, the weak, and the electromagnetic interaction, existed in the form of a single, unified force. If we penetrate even deeper into this area of speculative physics, we see that the physical world consisted of a kind of hodgepodge of short-lived elementary particles. Among them were quarks, the building blocks of protons and electrons. The relationship between matter and antimatter was balanced. Each type of matter particle had an almost mirror image counterpart made of antimatter. If these two particles, which differ from each other only in one aspect, ever met, they destroyed each other. But how were these particles formed? In this respect, the quantum field theory says that even a vacuum, considered the prime example of an empty space, is in reality bristling with physical activity. This occurs in the form of energy fluctuations and can cause particles to appear, only to disappear again. Consequently, the vacuum of space-time is also characterized by such processes. Here too, particles seem to appear out of the proverbial void. If we stretch our central question further, we come to another obstacle. How then did space-time come into existence? In this respect, the Planck era impressively demonstrates to us that we eventually come up against insurmountable barriers with our physical theories. In detail, the conceivably short-lived Planck epoch covers the immediate period after the Big Bang. At this point, space and time themselves became part of quantum fluctuations. The problem? Comprehensively understand the Planck era, we need a complete theory of quantum gravity that unifies quantum physics with relativity. M-theory and loop quantum gravity are considered promising candidates in this regard. Here, ordinary space and time are commonly regarded as emergent. Consequently, what we perceive as space and time is in fact the result of quantum processes occurring at a microscopic level that is incomprehensible to us. Since our common understanding of space and time is no longer valid in the Planck era, our classical conception of cause and effect also reaches its limits. Nevertheless, all the theories devoted to this section describe something physical that was happening at that time, a kind of quantum precursor of space and time. Even if our understanding of causality does not apply in the Planck era, it might be theoretically possible to fathom one component of that era with the help of another. However, our current theories are not capable of handling this challenging endeavor. Before the corresponding doctrines are fully developed, we cannot make any generally valid statements about the central formation processes of the cosmos. At present, it remains to be stated that physicists don't know any confirmed cases in which something has formed from nothing. Creator, multiverse, or cycles? Since it is currently impossible for us to decipher the quantum state of the universe at the beginning of the Planck era, all theories in this regard remain highly speculative. Some try to explain this central mystery by the influence of a divine creator. Other, less religious explanations see the existence of a multiverse as the most promising approach. According to this, the cosmos would not be an all-encompassing construct, but only a tiny link in an infinite chain of other universes. On the other hand, there are the cyclic models. The corresponding theses are based on the fact that the universe is subject to a constant cycle of destruction and rebirth, an exciting approach which has a prominent supporter with the Nobel Prize winner Roger Penrose. The British physicist once led the theory of the conformal cyclic cosmology into the field. If one follows the explanations of this expert, there are striking mathematical parallels between the Big Bang and the distant end of the universe. In fact, these two states are even identical when they are brought to their limits. This circumstance led Penrose to a hypothesis which seems extremely paradoxical. It was the complete absence of matter which produced all matter in the cosmos. From this point of view, the Big Bang therefore originates from something which comes closest to the ominous nothing, namely, what remains when the matter of a universe has been annihilated by black holes that have subsequently decayed into photons. But how is it possible that a cold, empty universe corresponds to a hot, dense universe from a mathematical point of view? The answer to this question lies in a sophisticated mathematical procedure called conformal scaling. This is a geometric transformation that changes the size of an object but leaves its shape untouched. And indeed, in this way, it's impossible to scale the states of the universe so that the shapes of their space-times coincide. In other words, the hot, dense state exists because of the cold, empty state. Thus, the end of an expanding cosmos is eventually followed by a new Big Bang. The search for the nothing. Let's assume that Penrose's controversial theory is confirmed one day. Even in that case, we still wouldn't have an answer to the question of how something can come from nothing. Where does physical reality come from? How was the cycle system of the universe formed? Why does anything exist at all and not nothing? Can there be such a thing as nothing at all? If by this is meant the absence of everything, how can something exist that does not exist? As you can see, it doesn't take long before some philosophical questions creep into this exciting topic. For our video today, however, we would like to stay in the realm of physics for once. So what does science have to say about the possible background of the cycles? One approach says that there could be no physical explanation for this at all. Or it's about an endless change of repeating cycles, where the initial quantum state of every cosmos conditions the properties of the following universe. Furthermore, it's conceivable that only a single cycle exists, with the beginning of the cosmic cycle being defined by a property of its end. Who knows if we will ever get an answer to the fundamental questions of the universe? But is it not just this great uncertainty that makes the topic so compelling? Time and again, researchers turn their gaze to remote areas of space to gain new insights into our galactic environment. However, investigating remote regions of the cosmos isn't always necessary, because sometimes they come to us. For example, smaller galactic objects regularly enter the Earth's atmosphere, serving up some important information about themselves and their origins on a silver platter. Such an event, which is by no means unusual, is thought to have been recorded in Papua New Guinea a few years ago. What's mysterious about this instance is that the discovery was hidden from the interested public all over the world. The secret meteor. The year is 2014, when the sky over Papua New Guinea briefly begins to glow. At that time, on January 8th, an object entered the Earth's atmosphere at an insane speed and subsequently burned up. Before that, the cosmic projectile had moved through space at a speed of more than 120,000 miles per hour, a really impressive speed, clearly exceeding the average speed of classic meteorites spinning past our domestic solar system. It was this extraordinary speed that provided the experts with a revealing insight into the origin of the meteorite. In a study conducted in 2019, experts concluded that the compact meteor, just under 2 feet in diameter, was 99% likely to have originated outside the solar system. It was possibly a structure that came from the deepest reaches of an alien planetary system. There's a thesis that the meteor originated in the dense disk of the Milky Way. Despite these remarkable findings and theories, however, the results of the scientific study were meticulously kept under wraps for a long time. The fact that we are only now learning about this exciting discovery is primarily due to the fact that some of the data needed to verify the calculations were classified as top secret by the US government. Since the interstellar trajectory of the object is now considered confirmed, it retroactively advances to become the first interstellar structure ever detected in our solar system. This title previously belonged to the object, Oumuamua, which has posed great mysteries to researchers since its discovery in October 2017. But more on that later. Amir Siraj, a theoretical astrophysicist at the renowned Harvard University and lead author of the study, now intends to publish the results of his work in a timely manner. This will make it possible for the international scientific community to extend the analyses. Since the meteor burned up over the South Pacific at the time, it's conceivable that some of its fragments landed in the sea. It's therefore possible that some fragments of the galactic projectile still lie dormant at the bottom of the ocean, waiting to be tracked down and studied. Although recovering this interstellar debris is like the proverbial search for a needle in a haystack, Siraj is already in intensive talks with other experts to discuss just such an expedition. Flying mystery. Before the true background on the origin of the 2014 meteor was revealed, Oumuamua was considered the first object observed within the solar system to be classified as interstellar. The groundbreaking discovery of the craft was made possible with the help of the Pan-STARRS telescope in Hawaii, where it was added to the star charts on October 19, 2017. However, by the time experts became aware of the existence of the unusual entity, it was already on its way back to interstellar space. Once again, astronomers describe interstellar objects as those bodies that are located in interstellar space, or in other words, the space far from a star, and are not gravitationally bound to a particular parent star. However, the objects in question may temporarily pass near a star during their journey through space. After scientists learned of the existence of our interstellar visitor, it raised a fundamental question. What exactly is Oumuamua all about? The first analysis of its orbital properties suggested that we are dealing with a classic comet. However, it wasn't long before this initial hypothesis was thrown into doubt, because Oumuamua does not have a characteristic tail. What we do know is that the object described the apex of its orbit on September 9, 2017. At that very moment, the structure was temporarily moving around the sun at over 50 miles per second, approaching within about 20 million miles of our central host star. A little over a month later, Oumuamua then went head-to-toe with our blue home planet when it passed Earth at a closest distance of about 15 million miles. Since then, the interstellar body has been on course for the constellation Pegasus. In addition to all these objective findings about the trajectory of the object, there were also some unexpected observations, things researchers still cannot explain exactly. Among them, for example, is the fact that Oumuamua slowed down somewhat less after its solar passage than the experts had predicted. This circumstance cannot be explained by the pure influence of gravity. At first, it was speculated that the additional acceleration could be attributed to the outgassing of volatile components. Such an outgassing, caused by the proximity to the sun, would have led in all probability to a drastic change of rotation. In fact, however, this was not detected. To gain further insight into the characteristics of this flying mystery, Oumuamua was observed by numerous modern telescopes. During the analyses, it became clear that the object undergoes dramatic fluctuations in brightness, a characteristic that suggests that the structure has the shape of an oversized cigar. However, the analysis of the photometric data collected was not sufficient to explain the unusually strong brightness fluctuations with a corresponding rotation speed. Thus, it seems that Oumuamua does not rotate around one of its main axes during its flight, but rather staggers through space. It's likely the object already showed this motion pattern when it left its home system. All these unexpected observations and characteristics finally led to a central question. Is it possible that Oumuamua has no natural origin, but was artificially created? An alien spacecraft? This controversial speculation was also fueled by the fact that no dust particles could be identified in the immediate vicinity of the ominous body. This in turn leads to the assumption that Oumuamua does not contain any water and possibly consists entirely of metal. Since the surface of the object was exposed to an incessant bombardment of cosmic rays during its billion-year journey, the experts assume a comparatively low reflectivity, assuming that the albedo is 0.04. The mean diameter of the missile would be about 700 feet. In November 2018, astrophysicists Avi Loeb and Shmuel Bialy hit the headlines when they tried to justify the absence of dust and orbital deviation with an unconventional hypothesis. Thus, the corresponding observations could well be explained by an extremely thin, large surface area body that was deflected from its ancestral orbit under the influence of the sun's radiation pressure. Possibly, so the two Israeli experts think, Oumuamua is an extraterrestrial solar sail sent by an intelligent civilization to research our solar system. An unusual assumption, which was not categorically rejected by other researchers. In fact, in December 2017, some researchers decided to take a closer look at Oumuamua as part of the Breakthrough Listen research project. To this end, the entity was analyzed by the radio telescope at the Green Bank Observatory in West Virginia. The goal of this endeavor was to register possible signals of artificial origin. Although it was considered extremely unlikely that we'd encounter radio signatures of an extraterrestrial species in the run-up to the work, the scientists nevertheless saw the investigation of Oumuamua as a worthwhile, unique opportunity. Over a period of 14 days, the interstellar object was analyzed in different frequency ranges. However, the evaluation brought the sobering realization that no evidence of an artificial background could be found. Future investigations. To reveal the true background of our mysterious visitor, a direct investigation seems most promising. But how do you intercept a craft traveling away from us at more than 15 miles per second? It would be virtually impossible for conventional space probes to reach Oumuamua. In order to get to the bottom of this exciting mystery one day, new approaches would have to be taken. One such concept is based on a literally explosive approach. An unmanned spacecraft could be ejected from our solar system by igniting a solid fuel engine. Once such technology is fully developed, it would be possible to reach Oumuamua within 16 years of the launch of the terrestrial spacecraft. However, patience will be required before this can happen. Those who do not believe in an artificial origin of the object sometimes suspect that it could be the fragment of a Pluto-like exoplanet. According to this view, Oumuamua would consist mainly of frozen nitrogen. However, the interstellar structure would have already lost most of its original mass. During its journey, large parts of the nitrogen ice melted so that the once clearly more massive body took on a flat form. Black holes are not only one of the most impressive, but also one of the most puzzling entities the cosmos has to offer. While experts have successfully deciphered many of the fundamental characteristics of these gravity monsters in recent years, one question has remained unanswered. How are supermassive black holes formed? While we now know that the particularly large representatives of this class of objects grace the centers of nearly all galaxies, how they themselves are created is still a galactic mystery. A breathtaking discovery could, however, bring some light into the cosmic darkness. For the first time, researchers have tracked down the precursor of a supermassive black hole. In today's video, you'll find out what this sensational discovery is all about and what puzzles still need to be solved in the future. Mysterious omnivores. Whether it's matter, radiation, or any other form of information, anything that winds up in the grip of a black hole is irretrievably lost. This is the fundamental characteristic that nothing that has passed the event horizon of a black hole can leave it again. A breathtaking as well as frightening property, which is due to the incomparably strong gravitational force of black holes. This in turn is created by the extreme compactness of the objects. If a black hole possessed the same mass as our Earth, it would not be much larger than a speck of dust. However, a look at the astronomical reality shows that the gravity monsters are significantly more massive than our blue home planet. According to this, there are black holes in the gigantic expanses of the cosmos that exceed the mass of our sun by a factor of millions or even billions. In principle, however, all black holes are not created equal. The easiest to understand are the basic mechanisms of so-called stellar black holes. As the name of this subclass suggests, these are objects that emerge from stars. When a star of a certain size has reached the final stage of its existence, it ejects its outer layers in a supernova. What remains is the stellar core, which collapses due to its own gravitational pressure to an incomparably compact structure, a stellar black hole. As mentioned at the beginning, black holes devour everything that crosses their galactic orbit. In view of this fact, one might think that the mass monsters destroy everything that approaches them up to a distance of some light years. However, in truth, the exact opposite is the case. It's considered certain now that supermassive black holes play fundamental roles in the development of galaxies. In fact, outside their event horizons, these gravity monsters behave just like conventional mass bodies. Therefore, it's easily possible for another celestial body to rotate on a stable orbit around a black hole. A groundbreaking discovery. Unfortunately, what is true for stellar black holes does not translate seamlessly to their supermassive counterparts. While experts can trace the formation of stellar black holes in detail, the birth of their significantly more massive counterparts has always resembled a formidable mystery. To get one step closer to solving this cosmic mystery, data and observations are needed above all. And in fact, astronomers recently scored a bullseye in this regard with the scientific designation GNZ7Q. Experts suspect that the detected object could indeed be the precursor of a supermassive black hole. In detail, the sensational discovery was recorded in a galaxy from the early days of the universe and possibly represents the missing piece of the puzzle within the star-forming galaxies and the first supermassive black holes of the cosmos. Observations in the ultraviolet and infrared spectra showed that a black hole is growing inside the galaxy under study. Until now, the most distant objects were either so-called starburst galaxies, known for their enormous star formation rate, or galaxies with incredibly active supermassive black holes that outshine the light of all surrounding stars, so-called quasars. In the case of GNZ7Q, at first glance, it appears to be a classic starburst galaxy. However, the information gathered during the in-depth investigation suggests that the central black hole is in the process of transforming into a quasar. In this regard, analysis of the object across the electromagnetic spectrum is in exact agreement with predictions from theoretical simulations. In detail, the corresponding galaxy produces about 1,600 sun-like stars per year, exceeding the corresponding formation rate of our local Milky Way galaxy many times over. The emitted UV light matches the characteristic accretion disk that typically surrounds a supermassive black hole. However, no X-ray emission has yet been detected in these central regions. This circumstance suggests the conclusion that the future supermassive black hole is currently still completely enveloped in gas and dust. Such a scenario has so far only been predicted in computer simulations, never directly observed. Accordingly, GNZ 7Q is considered a promising candidate when it comes to the question of the missing link between starburst galaxies and quasars. Astronomers plan to study the structure in the future using the James Webb Space Telescope. If everything goes according to plan, the complex instrument will begin its scientific service in a few months and provide us with a previously unknown insight into the greatest mysteries of the cosmos. Sagittarius A star. While it's now considered certain that the galaxies of the universe would not exist in this form without the participation of their central black holes, how exactly the formation of the gravity monsters is related to the evolution of planets, stars, etc., is not known. What, depending on the estimation, is true for most, or even for all spiral galaxies, is of course also true for our Milky Way. That is, in the heart of our home galaxy there is a black hole, which effortlessly dwarfs the usual magnitudes of the solar system. Sagittarius A star, as the object is scientifically called, has an incredible 4.3 million solar masses. Situated in the constellation Sagittarius, a distance of about 26,670 light-years gapes between the monstrous structure and our blue home planet. Due to its extreme compactness, the diameter of the event horizon is about 13 million miles. Recent investigations indicate that the black hole was active a long time ago, which means that our Milky Way could have been an active galaxy once too. Back in the early 1930s, US physicist Carl Jansky came across an unusually intense source of radio waves in the constellation Sagittarius. More than 4 decades passed before the ominous object responsible for it was identified, however. Using the interferometer at the National Radio Astronomy Observatory in Virginia, researchers Robert Brown and Bruce Balick succeeded in adding Sagittarius A star to the star charts in 1974. However, the fact that it's most likely a supermassive black hole was not proven until a series of observations over several years that began in the 1990s. Later, lead researchers Reinhard Genzel and Andrea Ghez would be honored for their discovery with the Nobel Prize in Physics. Investigation of the region in question soon yielded the realization that some remarkable spectacles were taking place in the immediate vicinity of Sagittarius A star. These included the observation of a star approaching the central black hole to within 10 billion miles. Experts later discovered that the 15 solar mass celestial body was rotating around the gravity monster at speeds of over 3,000 miles per second. In the course of the following years, it became clear that the glistening bright body is in the best company. The central mass monster is orbited by a whole series of other stars. Since these objects sometimes come dangerously close to the black hole on their orbits, they could belong to the so-called Quasar class. This currently exists only in theory and describes a type of star that is strongly squeezed as a result of enormous tidal forces. No less exciting was the discovery and observation of the G objects. One of them, the gas cloud G2, approached Sagittarius A star by up to 15 billion miles. Thereupon, the cloud was practically torn apart and brightly illuminated by the radiation of surrounding stars. So far, we know of 6 such G objects moving in orbit in the realms of our central black hole. On average, these objects have an extension of about 100 astronomical units. The length of the astronomical unit corresponds to the approximate average distance between the Earth and the Sun and can be estimated at about 90 million miles. If the G objects come into contact with Sagittarius A star during their journey, they expand even further as a result of the forces acting on them. While the black hole at the heart of the Milky Way is often the focus of scientific interest, we should not forget that it's by no means the only representative of this class of objects in our home galaxy. At the beginning of 2005, strong outbursts of brightness were registered in the vicinity of Sagittarius A star, suggesting that there are 10,000 to 20,000 other black holes in its vicinity. Their supermassive counterpart serves as a gravitational fixed point for these gravity monsters. This finding also fuels a theory that has been the subject of controversial debate for several years. The corresponding thesis is based on the fact that large central black holes are regularly supplied with material by their smaller counterparts. In detail, this galactic feeding is supposed to happen as follows. The small black holes bind stars in the outer regions of the Milky Way, which lead them on their orbit to the immediate vicinity of Sagittarius A star. Once there, some stars are finally detached and consumed by the elemental forces of the supermassive object. The cosmos is known above all for two characteristics: its exuberant diversity and the elemental forces at work within it. When a massive star has reached the last stage of its natural span of existence, it seals its own end with an explosive farewell, a so-called supernova. The findings that experts obtain in the course of studying these stellar deaths regularly bring home to us the fascinating uniqueness of such spectacles. In today's video, we'll show you how researchers recently succeeded in identifying a new nova record holder and the sheer incredible emissions that were released during the process. When stars die. Once a massive star enters the final chapter of its cosmic life, it's time for a brutal, radiant farewell. The process of supernova refers to the short-lived, intense illumination of a star that comes from a gigantic explosion. How extreme these stellar deaths can be becomes clear to us if we keep in mind that the luminosity of the celestial body can increase billions of times in the course of a supernova. Sometimes the star briefly shines even as brightly as a full-grown galaxy. Within a few seconds, about 1 pho of observable energy is released. To understand how this value fits into the overall galactic context, it's worth taking a look at our Sun. If our host star would have its current luminosity during its whole lifetime, it would release about 1.2 pho of energy. As a reminder, it's estimated that the Sun's own fuel is sufficient for a total of 10 to 13 billion years. Basically, there are two basic mechanisms that can cause stars to go supernova. On the one hand, there are those stars whose initial mass is more than 8 solar masses. If the nuclear fuel of the celestial body is completely used up, its life ends in the course of a so-called Type II explosion. After the hydrogen in the stellar core has fused into helium, the internal pressure of the star also drops dramatically. As a result, the celestial body collapses under the influence of its own gravity. The resulting increase in temperature and density in turn sets another fusion stage in motion, the 3-alpha process. In this process, 3 helium nuclei are converted into carbon by nuclear fusion reactions inside stars, emitting gamma radiation. This process repeats a few times, with carbon burning to form neon. Finally, after a series of further fusion processes, the time comes when the stellar burning processes come to a complete halt. As a result, the hydrostatic equilibrium of the star is severely affected. The oppositely acting gravitational pressure literally presses the celestial body into itself. As a result, the outer layers also fall towards the center, where they finally come into contact with the hottest part of the star, the iron-nickel core. However, the incoming shock wave is thrown back by this massive, dense stellar heart, setting off the classic stellar collapse supernova as the shock wave now bounces outward. What remains of the progenitor star after this glistening explosion is decided by the remaining mass, which collapses. Usually, stellar death ends in the formation of a neutron star, which typically weighs between 1.2 and 2.0 solar masses. Due to their extreme compactness, these stellar remnants have radii of only 6 to 7 miles. Moreover, these objects are the densest known formations without an event horizon. Besides their strong magnetic fields, neutron stars are known for one special property: their insane intrinsic rotation speed. The current record holder in this category achieves an incredible 716 revolutions per second. This corresponds to almost a quarter of the speed of light. However, it's also possible that the death of the star will result in the birth of a stellar black hole. These equally fascinating and frightening formations are created when the star's core collapses into an incomparably compact body due to its gravitational pressure. The gravity generated by this compactness is so strong that black holes become galactic omnivores. Nothing that has passed the event horizon of a black hole can cross it again from the inside out. When exactly the progenitor star meets its prescribed fate is defined by its initial mass. The heavier the star, the shorter its cosmic life expectancy. Type 1a supernovae. As mentioned earlier, in addition to this well-known basic mechanism, another exists that can transform a star into a supernova. While the Type II explosion is still due to the drying up of stellar fuel and the associated consequences, a Type 1a supernova involves two celestial bodies at once. This double star system consists of a white dwarf and its companion, As a reminder, white dwarfs are small, compact, old stars with very low luminosity. Over the years, the white dwarf accretes more and more gas from the expanding envelope of its companion. As a result of this transfer of material, several nova outbursts can be set in motion, a term that should not be confused with the term supernova. A nova describes a burst of brightness in a binary that originates from an explosive ignition of hydrogen burning on the surface of a white dwarf. In the course of these outbursts, the hydrogen of the ingested gas thus fuses until the white dwarf has enriched its core with enormous amounts of contaminated carbon. Further combustion and accretion processes cause the stellar core, which now resembles an oversized diamond, to become steadily more unstable. Once the limiting mass is reached, the entire carbon supply is burned to nickel and iron within fractions of a second, which means that it detonates as a Type 1a supernova. Unlike a core collapse supernova, however, no compact object such as a neutron star or stellar black hole remains. The matter of the dying white dwarf is completely catapulted into the gigantic expanses of space. Also, the companion star is not unaffected by this primordial event. It transforms into a so-called runaway star due to the high orbital velocity with which it once orbited the white dwarf before. It literally flies away. Violent nova eruption. Now that we have taken a look at the two best-known basic types of supernovae, it's time to take a look at an exciting discovery that researchers made just a short time ago. In detail, the researchers were dealing with the precursor of a Type 1a supernova. The system that became the focus of scientific interest is called RS Ophiuchi, as the researchers from the Max Planck Institute in Munich discovered during their investigation. The nova outbursts were accompanied by an unusually intense emission of gamma rays. About 5,000 light-years from our blue home planet, a white dwarf in the eponymous constellation Ophiuchus incessantly accretes material from its companion, a red giant star. As briefly described earlier, the absorption of hydrogen gas on the surface of the white dwarf sometimes leads to overheating that sets off violent thermonuclear explosions. These violent events usually follow a fixed cycle. In the case of RS Ophiuchi, about 15 years elapse between nova eruptions. Finally, the most recent nova observed by experts was accompanied by an unexpectedly high gamma ray burst. In detail, the emission, which was registered and analyzed with the help of the two magic telescopes on the Canary Islands, reached an incredible value of 250 giga-electron-volts. This is one of the most intense gamma ray bursts ever observed by astronomers. The explosion produced shock waves that accelerated particles to near the speed of light. Based on their collected data, the scientists concluded that the gamma rays originate in energetic protons, the nuclei of hydrogen atoms. In other words, nova eruptions are also sources of cosmic rays. This means a high-energy particle radiation, which is mainly composed of protons, but also of electrons and completely ionized atoms. The corresponding particles move through the gigantic expanses of the cosmos at almost the speed of light. Compared to the enormous shock fronts generated by supernovae, however, the forces released by nova outbursts are significantly less intense. One day, RS Ophiuchi will also be torn apart as part of a Type 1a supernova. However, a look at the experts' next discovery shows that not all objects want to follow the supposedly fixed rules of the cosmos. Stellar death throes. When a massive star goes supernova, it shines brighter than full-grown galaxies for a few days, before rapidly losing luminosity afterwards, a supposedly fixed scheme, which went completely ad absurdum. In the case of the object IPFT 14HLS, astronomers like Stan Woosley, who dedicated themselves to the investigation of the structure, called this simply bizarre. The background? It seems as if the star in question simply does not want to die. Originally discovered in September 2014, the stellar explosion was initially thought to be a perfectly ordinary supernova. However, when an attentive intern sifted through the collected data, again 5 months later, he came across a puzzling detail. The supernova first became fainter, as expected, only then to shine brighter again afterwards. Even more puzzling is the fact that this was not a one-time phenomenon, but a reoccurring one. Over an observation period of 2 years, this interplay of dimming and intensification was registered 5 times. The analysis of the light spectrum paints a clear picture and perfectly matches the basic characteristics of supernovae, ruling out any other event. Never before have experts been confronted with a supernova lasting years. Normally, dying stars go out completely after about 3 months. But that's not all. A review of archival images showed that another stellar explosion had occurred at exactly the same location in 1954, but had been overlooked at the time. The question of what is behind this supernova hiccup is still the subject of research. Now we want your opinion. What do you think about the stellar explosion spectacles that regularly occur in the cosmos? Drop us your thoughts, suggestions, and feedback on today's video in the comments below. Still in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which we have linked for you here in the credits. Thanks for your interest, take care, and we'll see you next time.